Assalamu alaikum. Myself, Dr. Ansari Farzana, Zama, Department of Chemistry, J.A.T. Arts, Science and Commerce College for Women, Malegaon. Welcome all of you. In previous section, we have seen different component used during the calorimetric analysis. That means different component of calorimeter. And we have seen the absorption filter. Filter are of two types: absorption filter and the interference filter. This is the simple peak transmittance and band pass width of a filter, absorption filter. Every calorimeter provides with set of 12 filter with peak transmitted absorption filter are generally cheaper than interference filter. Interference filter. These filters generally provide somewhat narrower bandwidth as low as 10 nm. Then absorption type filter. In order to prepare the filter, a semi-transparent metal film is deposited on the plate of glass. Then it is coated with a thin layer of some dielectric transparent material like MgF2, followed by another coating of thin film of metal and another plate of glass for mechanical protection. This filter works under the interface phenomena at desired wavelength, thus neglecting unwanted radiation by selective reflection. When a ray of light is incident upon it, a part of light reflected back whereas remaining light is transmitted. The part of incident radiation is reflected repeatedly by the semi-transparent metal film, but at each reflection, some radiation are transmitted out. The outgoing radiation undergo constructive interface for those wavelengths which are exactly even multiple of distance separating the two metal film. For remaining wavelength, radiation beam undergo destructive interface and thus corresponding energy is not passed out. By varying the distance between the metal film, the wavelength range can be modified. This is the simple interference filter. See here, this is the incident radiation. Some part of incident radiation, desired wavelength of radiation is passing through it and remaining is refracted. And it meet in the path of incident light. The desired wavelength of light is passed through it and remaining is reflected. Then it meet in the path of incident radiation. Desired wavelength of radiation is passed out, transmitted and remaining is reflected. This is the simple work of interference filter. The equation which gives the wavelength of transmitted radiation is given as m lambda is equal to 2d n sine theta, where 2 is nothing but wavelength of transmitted light, m order of reflection, whole number of multiple of the transmitted wavelength, d is the distance of separation of metal film, n is the refractive index of spacer or angle of incidence. Monochromator. A monochromator is a device which converts polychromatic radiation to monochromatic radiation. Usually, a monochromator consists of entrance and exit slit. They restricted unwanted radiation and help to control the spectral purity of radiation emitted from the monochromatic. Lenses or mirror to make the beam parallel or to focus radiation, and the dispersing medium like prism, diffraction grating to isolate the wavelength from polychromatic radiation of source. Prism is a suitable dispersing element that can isolate a selected band of wavelength. It is triangular shaped piece of glass or quartz. Light is admitted through an entrance slit, then it is collimated with lens. It enters into the prism and gets dispersed by the refraction. It is shown in the figure, in this figure. Okay. See in this figure, light is refracted to different degree depending on their wavelength. Shorter wavelengths are refracted more than longer wavelength. Any desired portion of the resulting spectrum can be made to pass through a sample by the rotation of prism. Usually, normal glass prism are used for visible range, quartz for ultraviolet, and alkali halide for infrared region. Diffraction grating. This is the simple diffraction of radiation from the grating. A diffraction grating is a suitable dispersing element that can isolate a selected band of wavelength. It is prepared by carefully rolling or etching a large number of parallel equidistant grooves upon the highly polished metallic surface like alumina. Generally 15,000 to 30,000 line or grooves per square inch are drawn for ultraviolet and visible region. The grooves acts as a scattering center for rays incident on the grating. Thus the light diffracted or spread out over a range of angle and in certain direction reinforcement or constructive interface may be takes place. When polychromatic radiation is incident on the diffraction grating, the equation n lambda is equal to d sine I and d sine I plus sine r. N lambda is equal to d sine I plus sine r. This is the simple equation can only be satisfied for a single wavelength at a time. Rotation of grating to change the angle of incident I will bring each wavelength in turns to the position to satisfy the equation. This results to give a monochromatic beam. The construction of the grating is very costly and difficult. Therefore, replica grating are prepared from an original grating. It is prepared by coating the original grating with a film of epoxy resin, which after setting is removed to form replica. The replica thus obtained is made reflective by aluminizing its surface. The distance of prism is that they undergo dispersion, giving wavelength which do not overlap. But the disadvantage of prism is that they give nonlinear dispersion. This can be compared with the grating. The grating give linear dispersion, but they suffer from an overlap of spectral order. Cuvette or sample container. The cell holding the sample or solvent should be transparent to wavelength region under study. This cell is called as cuvette. Cuvette made up of glass or quartz is used in visible region and that made of quartz in ultraviolet region. The cuvette may be rectangular or cylindrical in shape. The internal distance or diameter of cuvette is generally 1 centimeter. Detection of radiation. The detector is a device which converts radiant energy into electrical energy. Generally, three types of detector are used to detect radiation, and these are photovoltaic cell, or also called as barrier layer cell, phototube, or also called as photo MAC tube, and photomultiplier tube. Photovoltaic cell. This is simple. A photovoltaic cell. It consists of base plate, metal base plate made up of iron or copper. This is the metal base plate which acts as one electrode. A thin layer of semiconducting material like cesium is deposited on the surface of metal surface. In on that, then the surface of semiconducting material is covered by a very thin layer of silver or gold which acts as a second collector electrode. When the radiation is incident upon the surface of semiconducting material, selenium, electrons are generated at selenium-silver interface. These electrons are collected by the silver metal plate and accumulate on the silver surface. It creates an electric voltage difference between the silver surface and the base of the cell. The external circuit has low resistance and therefore a photocurrent flow through the outer circuit. The photocurrent is recorded by galvanometer in the circuit. The magnitude of photocurrent is directly proportional to radiant power of incident radiation. Thank you for watching.